Okay, this is another episode of the Mentor Robot. I've been playing with, in the past I've been using what I would have referred to as time delays to get the robot to a position before it moved to the next position. So just to explain that, if you tell the robot to move the rotary axis, the waist axis, and it actually goes from 0 to 255. But if you told it to go to 255 and it was travelling from 0, and then you told the next axis to move, that axis would start moving before the first axis had reached what we call total coincidence. So to get round that, I used 4 next loops to make it delay. What I've been playing with today is reading back the analog to digital converter so that I can tell when it's reached a position. This just have a look at the robot. This relies on the accuracy of calibration, which I haven't got exactly right at the moment. So if I just run this particular program, if I just run this, oops, let's just put that properly. If I run this particular program, it's going to ask me for a tolerance. I'll come back to that in a second, but if I just put that, say at 2, and set it to midway, and that will run and the robot will start to move. So there you go, it's starting to move, and there it is. Now the pot value that comes back is 131, and that's because the pot calibration isn't exactly right. It's 3 bits out. So if I run that program again, but let's give it a tolerance this time of 3, but I'll send it somewhere else. Let's send it to 20. Oops. So it moves, starts counting down. There it is. Now this time it's a total coincidence because it's within tolerance, 23. Let me just have a look at the code that does that. Just clear the screen, input what you want the tolerance to be, what is the address. In this case, FD00 relates to the waist axis. I've told it it's axis 0. This is done for later on. Ask it what position you want it to go to, and then we go through a repeat until loop. This code here is addressing the analog to digital converter. So in this case, the address FD00 plus the axes, in this case it's 0, so that will be FD00. I've done that so I can just use different axes, so it's equal to the position, so it goes away and it drives that to a particular position. This bit here, the address plus 6 is equal to axis times 16. It's the actual channel that the ADC is on. So that says switch it on, read it. This says switch it off. We then get a pot value at the next address, which is 17 in this case. We then all I've done there is shown the pot value on the screen so I can see it actually moving, and it goes around here and it says do all of that until the pot value is equal to position plus tolerance, or the pot value is equal to position minus tolerance. And then when we've actually reached where we want to be, it'll say we're at total coincidence. So that's just that simple bit of code. So if I run that again, just to show you what it does, I'll give it a tolerance of 3, and I've got the light. If I set this to completely the other direction, I won't go to an end stop actually, I'll go to 250. So that starts counting, the robot is moving. When it gets there, it'll stop any second, and it says it's at 247, which is within plus or minus 3. So that's working. What I've now got to do is calibrate those pots properly to get them really accurate. There are all manner of other things to consider here, because there's backlash in the gears, and it's not that accurate anyway. So if I can get tolerance within plus or minus 1, I'd be happy. Well, I'll be happy with plus or minus 2 actually, but 3 might be a bit dodgy. It's not quite right, so we'll see how it goes. Thanks for watching.